Okay, so here we see that we have to either add or subtract or multiply or divide both sides by a constant. So in my previous video last week that I've uploaded, I did explain the concept of why we are specifically saying by dividing, subtracting, multiplying, adding by a constant. It's because a constant is defined as that value, that fixed value that we are transposing, or that fixed value that we are moving over the equal sign. So we're not yet at our shortcut, okay? So later on this week within the planning, we'll see that we move on. We're still doing the same work, but by Wednesday's planning, I said shortcut for solving. And that shortcut, if you are already using it, that's also fine. I'm going to just demonstrate what it means. If I have x plus 2 is equal to 10, my shortcut would say simply 10 minus 2, x is equal to 8. That's my shortcut. What exactly did I do? I eliminated the concept of doing the inverse of what I see here and writing that step down. That's the only shortcut there is. So let's go back to the long way of doing it. Just for those who are willing or ready to move on to skipping this step, I said, how do we undo the plus 2? We take it away. What we do to that side, we do to that side. Therefore, I have x plus 0. That's basically what I want. I want a plus 0 from there. That plus 0 allows me to say x is therefore equal to 10 minus 2, which is 8. Okay, so that's a very, very easy and basic example, but we'll have to do a little bit more complicated ones. Now, what I want to do today is just to poke around and to find those challenging sums that look slightly different, but it also says then to check your answers. So to check your answers, we need to check that our left-hand side is indeed equal to our right-hand side. So left-hand side must always be equal to right-hand side. And the way we check is to substitute our answer back into our equation. Okay, so let's just do 1 or 2. I've seen some here that I assume would maybe cause a little bit of problems, and I've chosen some out of our exercise set here that it's got some negatives. So I'd like to do exercise 3, number 11, for example. I'd like to just focus on what to do when that negative is there, and I'm going to continue to do it in the process that I started with seeing what are we taking away or adding in order to use our inverse operation. So in this case, I've also suggested from the very beginning, keep your equal signs aligned. In this way, you're able to see on which side are you working. You're working on a left-hand side and you're working on a right-hand side, and it's your duty to do on this side what you do on that side. Either way, please understand that this minus x remains minus x. It does not change. The minus x is a fixed, it's a coefficient of minus 1. What's the coefficient of x here? It's minus 1. Now that minus 1 we need to treat with care. So I leave my minus 1. There's a minus 4. I leave a little gap. And then there's 1 on the right hand side, leave a little gap. And in that gap, I ask myself, what's the opposite of minus 4? How do I take minus 4 away? I add 4. And I add 4 on that side. Therefore, I'm keeping my equilibrium. But this is still minus x, okay? So that means minus x. This becomes 0. That's what I want. And my answer on the other side, on the right-hand side, is 1 plus 4 is 5. But I'm not done here, because what I actually have here is I have a minus 1 times x. That's what this is, okay? And it did not ask me to solve for minus x. It asked me to solve for x. Therefore, I need to eliminate this coefficient. So I will divide by minus 1. So I hope you've already noticed the trend here. The trend in solving for x will firstly be based on transposing. Now, transposing is a very fancy word. Trans means across. You are making sure that things are moving across. And that's what we do in our shortcut. We bring this across. So that's our first step. Why are we doing this? It's because we want to isolate x, okay? And then always, what's left is our second last step. Our second last step is always to assure that we are solving for x and x alone, okay? Therefore, we will use inverse operations. Right at the end, it will always be between division and multiplication. It's either or. That's always going to happen. And in this case, I want to undo multiplication by -1. So I'm going to rewrite. And I'm going to make sure that I indicate my division by -1 on the left-hand side as well as the right-hand side. I treat it equally. And now my minus divided by minus becomes a positive, and I'm able to solve for x, because the whole idea is to assure that we have a positive x to solve, okay? And whatever is in front of x, we need to get rid of it by performing our inverse operation. Now, what I do on this side, and therefore, is I am doing 5 divided by -1, which gives me a -5. Right, there's that one. Let's quickly look at number 15. Okay, number 15 is given as -3x is equal to -9. Okay, now I don't see any pluses and minuses. What did I see here? In this example, I had a plus and a minus. I had a -4. Here I only have one term equal to one term. So what we're doing here is we're actually at this point of the typical equation. We're at this point where there's no need for any plussing and minusing. There's only a need for isolating x, for performing the inverse operation. And at this point I ask myself, I'm given -3 times x, which is equal to -9. But how do I undo the multiplication? I undo it by using division. If I'm timesing by the -3, I will always divide by what is in front of x. I will always divide by the coefficient. And therefore I perform it on the other side, because what I do on the one side, I have to do on the other side. Right, now I can see, okay, -3 divided by -3 leaves me with a positive x. But what I do on that side, I have to do on this side. And here, minus divided by minus becomes a plus, very important. 9 divided by 3 becomes 3. And there's my answer. Now let's check. Let's do the check. We have to check if our answer is correct. How do we check? To check whether your answers are correct, you must show that what you have on the left-hand side is eventually equal to what you have on the right-hand side. Therefore, you must take your value that you have solved, x4, you take your original equation and you replace that x with what you found the solution to be, but you keep everything else. So here's my little x. I've just replaced my x, okay? But I keep my equation as it has been given. And I ask myself, what do I get here? What do I get? -3 times 3 is -9. Is that in fact equal to the -9 that's been given to me in my equation? Yes. Great. Therefore, my left-hand side is equal to my right-hand side. And this is a check, okay? This is your check. So that would, yep, 100%, you got it right. It works, okay? Right, let's quickly look at some of these other ones that might have also caused some confusion. Number 19. X over 7 is equal to 5. This means that something divided by 7 gives me 5. Now, we must understand in solving for x, in the process of solving for x, no one ever said x is not allowed to be a fraction. X is allowed to be any real number. Now, what does that mean? Let's just quickly backtrack. Numbers could be counting numbers, natural numbers, whole numbers, positive and negative integers. Integers over an integer become rational or irrational numbers. And these would be fractions, they would be decimals, they would be any type of value, okay? So as long as we don't have x, as long as we don't have x being 0 when something like this is given, I may not say that x is 0 here, okay? Because this would give me an undefined answer. So as long as this is not happening, I'm fine. As long as this is not the case, I'm happy. I can carry on. That's it. That's all you need to watch out for. You just need to make sure that x is always in the numerator, okay? Not in the denominator. And when x is in the denominator, just it mustn't be equal to 0. So now what I may do is I may ask myself, what do I see here? What it is it's x divided by 7 gives me 5. So how do I undo division by 7? Okay, so I say x over 7, and I multiplied by 7 over 1, because the multiplication by the inverse will take away the 7 right here, okay? It will cross cancel. The whole idea of doing this is to cross cancel. Therefore, I'm left with x. Therefore, I'm left with x. Always, therefore, no double equal sign. There shouldn't be an equal sign here and an equal sign there, okay? Make sure you have that in your workbooks. And therefore, I can now say 5 times 7 is in fact 35. How do I check? I go back to my original equation, and now I substitute what I found for x into my answer, and I test whether it is in fact true for the right hand side and the left hand side. And I see, right, my left hand side is in fact equal to my right hand side. Yay. And then you know you've done your work correctly. Okay. Let's also just look at some of these here. I want to do number 21. Number 21 shows us 2x divided by 3 is equal to 4. So this means you are multiplying x with something, then you are dividing it by 3, and then you're saying it's equal to 4. So let's just break that up a little bit. We are saying 2 times x, right? We get that answer, and then we're dividing it by 3, and then we're saying it's 4. So what would be the inverse? What are all the opposites? Opposite of multiplication would be division, and opposite of division would be multiplication. So how do I treat the opposite of this? Let me just move my x to stand next to the 2 over 3. And this is a very, very important aspect. We tested this in our first assignment where I gave you something that looked like this. And I asked, what is the coefficient of x? Now here, the coefficient of x is 5/8 minus 5/8, as I am allowed to move my x slightly next to the fraction. Okay, so bear in mind, whatever you see, you are allowed to rewrite this as this. It's the same thing. Now that I have the coefficient clear, all I need to do is apply the inverse operation. And what it does is it eliminates my existing 2 over 3x. Sorry, just the 2/3. And what I do to this side, I want to just put that 4 over 1, and I will do it to that side. So what did I do? I multiplied by 3 over 2 because I want to eliminate 2 over 3. So I'm applying my inverse operation. Inverse literally means your opposites. Opposite, okay? And what you do on this side, you must remember you have to do on that side. So now we can go ahead. Let's cancel. 3 cancels with 3, cross cancelling, 2 with 2, right? But now I want to also just sort this side out. Therefore, and I see, okay, you're either going to use your long way and get 12 divided by 2. That's one option. Or you're going to apply that cross-cancelling technique that I introduced to you last term if you haven't seen it before. 2 divided by 2 is 1. 4 divided by 2 is 2. 2 times 3, and I get 6. Right, but now I have to check it, right? I need to check my work because they've asked me to check. So I go back to what I've been given. 2 over 3x is equal to 4. And I plug this value into my answer, and I see, do I in fact have equal to 4? I'm putting 6 over 1 so that I can see how my fraction compares to this coefficient. I have 3 divided by 3 is 1. 6 divided by 3 is 2. 2 times 2 is 4. 4 is equal to 4. Left-hand side equal to right-hand side. If you didn't do the cross-cancelling here, you would have said 2 over 3 times 6 over 1. That also gives you 12 over 3, which still gives you 4, either way. But I'd like to encourage you to use the inverse operation because everything we do now relies on cross-cancelling. So that cross-cancelling concept, it will come around a lot more now. Okay, so that would be your way to check that. Then there are a few here towards the end of B, also still exercise 3. And I'd like to just make sure that you all understand how to do them. Okay, so let me just get one where x is not on my left-hand side. What we're used to is like when we read a book, right? When we read a book, we read our pages, we read from left to right, okay? We read this direction. And we go here and we read the next sentence and we read the next sentence. That's our book, okay? So from left-hand side to right-hand side. That's how we read normally. But, okay, now we are doing equations. We're working with equations. We're working with some maths equations, and we also continue to read our equation. Something x is equal to something, okay? But we don't always have x in the left-hand side. So now let's take, for example, number 14. 12 is equal to 15 plus 2x. Now, what we learn is that this equation that we have established here in maths allows us to read it this way as well as this way, okay? So if I say 3 plus 2 is equal to 5, then 5 is equal to 2 plus 3. What I've done is I've read it this way, and I've read it, the blue one, from right to left. Gives you the same answer, provided that I treat it carefully. So what I'm going to do is I'm going to rewrite what I have. And I'm going to see where's my x. Okay, here's my x. Okay, there's my term containing x. I want to isolate that term. I still want to get it on its own. So I want to take away the plus 15. Okay, how do I take away the plus 15? Make sure you understand the sign in front of this term. How do I take away plus 15? I subtract 15. But what I do on that side, I do on this side. Okay, and what I see now is that I have something that looks slightly different from all my other equations. Let's just continue. Here we need to be very careful. We have to be very careful with how we are performing our arithmetic here. So it's essential that we remember we're not allowed to just go and apply rules wherever we want. We must make sure that we're applying them in the correct context, okay? So this is 12, take away 15. 15 is greater than 12 and there's a negative there, which means my answer will be negative 3, okay? But it's equal to, now what do I get here is I get 0 and I have a positive 2x left. Okay, now what I see here is that minus 3 is equal to 2x, or that 2x is equal to minus 3. So you can continue to apply your rule here, provided that you are not switching signs for moving it. You're merely indicating the direction, okay? So this is in fact the same as 2x being equal to minus 3. Now this is where your comfort level is tested. You will need to find your choice, your level. Do you continue there or do you do your swap around and continue like that, okay? Either way, you're going to get the same answer. If I say minus 3 is equal to 2x, I ask myself, I want to solve for that x, so I'm still applying that inverse operation that I learnt about, and I divide both sides by 2, because I still want to only solve for x. But my x will now just be on the right-hand side, and I will leave this answer as is, okay? Because negative 3 over 2 is still negative 3 over 2. Or if I chose to make sure that I put x on this side, but I kept my positive 2x as it is, I kept the negative 3 as it is, the equation still is what it's how it's been given. I've kept the integrity of my equation. Then I can also still apply my inverse operation here, provided I understand how am I getting rid of my coefficient. I have a 2 times x, so I will divide by 2. What I do there, and my answer is still x is equal to negative 3 over 2. So that's fine. You may leave it like that, and you may go ahead and sort it out first, provided that you have done it correctly with all your signs. And now let's just check. We want to check, are we okay with this answer? Then let's go back to what was given to us. We were given 12 is equal to positive 15 plus 2x. 12 is equal to positive 15 plus 2. I am subbing this in. Minus 3 over 2. A lot of fraction work coming in here. 12 is equal to 15 plus, that's a 2 over 1 times a negative 3 over 2. What happens here is I cancel my 2. 12 is equal to 15 minus 3. 12 is equal to 15 minus 3 is 12. Left hand side is therefore equal to right hand side. So we're on the right track. Okay. And right here is where I've done my substitution. That would be the negative 3 is the result of cross cancelling. So it's a really important section in math where we have to apply that cross cancelling technique that we learned from dividing with fractions. It becomes a tip and times the reciprocal. Now, one last one here, if time allows. Let's quickly see how we would go about number 21. 21, 3 is equal to 3 over 4x minus 2. What would I want to do here? If I want to keep the order as it is also fine. Therefore, I will read to myself 3 is equal to this 3 over 4x. And I purposefully write this coefficient next to x because later on it will help my eye see what I need to do to perform the inverse operation. I first just want to isolate this term. I just want to get it on its own. So let's look at this term here. I want to do the opposite of minus 2 means plus 2. What I do to this side, I have to do to that side. And therefore 5 is equal to 3 over 4x. That gives me 0. Okay. And now I'm simply looking at the inverse operation. Therefore, 5 is equal to, what is the opposite of 3 divided by 4? The opposite would be to times by 4 over 3, which I then also do here. Times by 4 over 3. And if you can't cross cancel, it's fine. Now I want to focus on that. That's going to leave me with x. Yes, that's what I wanted. And what do I have here? Here I have 4 over 3 times 5 over 1. That is 20 over 3 is equal to x. And you may change that into a mixed number, but it is not going to be wrong if you leave it as an improper fraction. So very important, I've kept my x on my right hand side, but it still reads the same as x being equal to 20 over 3. Provided that you keep to your rules. And then if you do your check, substitute that value in there. So let's just stick to our rules. Our rules are very important and you will become more comfortable. You will learn what works.